This presentation is an assessment of the vegetation management technique in the Golden Gate National Recreation Area using remote sensing data. This presentation is brought to you by Abdullah and Andrew of the Geospatial Analysis Lab at the University of San Francisco. Climate change and land use change has negatively impacted terrestrial ecosystem. Land conservancies have been formed over the past few decades by various governmental and non-governmental organizations to preserve, protect, and restore the impacted natural area. In the San Francisco Bay Area, the Golden Gate Recreation Area, or GOGA, is the largest of such conservancies and was founded and managed by the Federal National Park Service. Our assessment aims to evaluate the effectiveness of conservancy strategy in GOGA by comparing the performance of federal managed ecosystem to other land management practices nearby. Currently, the management strategies are evaluated in simple terms, such as total acreage protected, or in detailed localized data, such as species count and water quality sampling. Unfortunately, measures such as these are too general or are time and labor intensive. Rather than using this method, our assessment aims to use the Enhanced Vegetation Index, a type of remote sensing data gathered by NASA modest satellites, to quickly and effectively create a measurement of ecosystem performance from which we can compare management strategies.
To begin our assessment, shapefiles of protected land ownership boundaries were intersected with vegetation boundaries to create our study area. Our value data was provided by 16-day, 250-meter sinusoidal grid Aquamodus vegetation index data from NASA's Earth Data website. The study area contained a great deal of coastline and marshland, so Aquamodus was chosen over Terra Modus for better coverage. Since this was a preliminary project, data was limited to 3 measures: the EVI for the month of April for every year from 2002 to 2017, the month of September for every year from 2002 to 2017, and a full 2-year spectrum of data from March 2016 to March 2018. These data sets were chosen because the month series covered long-term trends over 2 different seasons, and the 2-year spectrum provides a good recent baseline of EVI. Once the data was gathered, we ran an iterated zonal statistics tool to calculate the mean EVI by vegetation category and vegetation type for every EVI raster. The resulting data was then converted to Excel tables for data visualization. For the sake of time, the data used to calculate the results of this presentation was limited to the EVI data of coastal scrub vegetation areas. Coastal scrub was selected because it can be found in all protected lands and makes up a measurable amount of vegetation coverage in each. From the 2-year time series graph of coastal scrub EVI, we can see that at the peak growing season in late April, the GOGA coastal scrublands, labeled as federal on the graphs, perform well compared to other land conservancies. This finding is backed up in the long-term April and September time series graphs. Based on these findings, we can conclude that the current vegetation management strategies in GOGA are effective. Moving forward with these results, the data we have gathered and presented here will need to be refined before it can be used in any statistical analysis. It is well known that EVI data varies with precipitation, so the data will need to be normalized to see EVI performance variation outside of this variable. Once normalized, Backy analyses can be ran on areas that have had restoration activities performed to see if restoration has measurably improved vegetation performance. We would like to thank Megan and Fernanda for their help and guidance with this project, as well as Alan from Drone Shots for permission to use the GOGA aerial footage. This presentation was created as a requirement for the Intermediate GIS course at the University of San Francisco.